Alright, so we're going to go ahead and take a look at the area of polygons foldable. And this is the foldable that you're going to use to work with your students on looking at the area of polygons. So to start, what you'll want to do is you'll want to look at your doofus. And so your doofus problem solving method is what's going to help your students work through each of their problems. And so the D stands for drawing a picture. The U is where we're going to have them check their units, make sure that they don't need to do any conversions to go from feet to inches or yards to feet. The F stands for formula. This is where we're going to have them reference their STAR reference materials to make sure that they're using the right formula to solve a problem. A stands for algebra. That's where they're going to show their work and substitute in their numbers into their formula. And their S is their solution, where they're going to check the reasonableness and make sure that they've answered the question that was asked. Now your first shape is a rectangle, and most students should be able to tell you that the area of a rectangle is area equals base times height, or they may refer to it as length and width. Let's go ahead and have them label that their base is equal to 8 units and that their height is equal to 5 units. And then we can have students substitute in that area, we'll find it by doing 5 times 8, which gives us a total of 40 square units. And we want to remind students that when we're finding the area, we're covering it with square units. That's where we get these little squares. It takes 40 of these little squares to cover the rectangle, and that's how I find the area of the shape. And so just make sure that you have students label each part and substitute in for their formula to practice going through their doofus problem solving method. For your next shape, you want to convince students that you're starting with the same rectangle that you just finished with. And so go ahead and have them trace or outline the rectangle before they do anything to manipulate it to make the parallelogram, so that they're convinced, or that they can see that visual, that it's the same shape that we just dealt with. So now that we have that rectangle traced on our paper before we even glue it, then we can cut along the darkened line and then move that piece over to the other side of our rectangle. And so we're showing students that I'm not doing anything to manipulate the area. All I'm doing is moving and transferring that area to another part of my shape to create my parallelogram. And so we can show students that my base is still the same. I still have a base of 8 units. My height is also still the same. My height is still a height of 5 units. I've just moved this I've just moved this little triangle over to the right side of my rectangle to make my parallelogram. And so inside, you can have students label again that I'm using the same formula. Area equals base times height, and my base is still 8, my height is still 5, so my area is still 40 square units, just like it was with my rectangle. Alright, so now let's look at the triangle and the trapezoid. For the triangle, just like the parallelogram, we want to show students that we're using the same size rectangle that we started with from the beginning. And so go ahead and have them trace or outline that rectangle on their paper before they do anything. But then when they cut along the solid line and take that away, we see that we've made a triangle. That triangle has been made by taking and cutting along that solid line. Now we want to show students that when we cut along that solid line, we cut our rectangle into 2 congruent pieces. So you can show students by flipping the piece that you cut off, like, look, they're the same size. What do we do if we cut something into 2 congruent pieces? And hopefully the students will be able to tell you, well, if I cut it into 2 congruent pieces, I'm cutting it in half. And so you'll say, aha, there we go. So all I'm doing is taking the same formula that I use with my rectangle, with my base of 8, and my height of 5, and if I take that formula, area equals base times height, what did I do to that rectangle? I cut it in half. How do you cut a number in half or a value in half? There are two ways. You can either divide it by 2, or you can take the area and multiply it by 1/2. Area equals half of your base times your height. And this second formula here is how your students will see it on their STAR reference materials. So you want to get them familiar with it. When I'm finding half of a number, I'm multiplying it by 1/2. So if I was going to fill in my numbers for this problem, and I'm running out of space, but you'll have more on your foldable, we could plug in our numbers going through our doofus problem solving method. We could, in our A, we could show that area equals 8 times 5 divided by 2. Or, sorry, I should have wrote that with the half. Let's rewrite it so that we can get our kids familiar with the half. Area equals half of 8 times 5. And so if I have area equals half of 8 times 5 is 40. That's the same area that we had for both our rectangle and our parallelogram, but half of that is 20 square units. And so that's the area of our triangle. So now let's look at our trapezoid. The trapezoid is going to be the trickiest of all the shapes to show, but go ahead and have your students start by cutting along the solid lines for their trapezoid so that they can take those two little pieces away. And then what you're going to have them do is use this shape and shade it twice. So you'll have them trace this trapezoid once, and then you'll have them trace it a second time. They'll take that same trapezoid, flip it around, turn it flush with the what they just drew, and then show how they could piece those together. Now this is where you're going to define the different parts of your trapezoid for your students. And so we're going to remind them that every trapezoid has two bases. And so we can label them. This would be base 1, and I'll label it as B1. But we want to show them that when I turned my trapezoid, base 1 is also represented down here on the bottom, B1. When I have my base 2 down here at the bottom, my B2, it's also represented up here as B2. And then just like my parallelogram, rectangle, and my triangle, it also has a height, and that height can be shown right here. It's the same height that we saw on all of our other shapes. Our height is going to be 5 there. There's my right angle for my height. My base 1 looks like it's 4. My base 2 is 8, so I'm going to go ahead and label those. Base 2 is 8. Base 1 is 4. Now what we want students to see here, and I apologize, I know there's a lot of different colors on here right now, but what we want students to see is that when I take these two congruent trapezoids and manipulate them around, the greater shape that's built here, and I'm going to show you in yellow, is a parallelogram. Okay, we want to show them that when I take two trapezoids and put them together, I get a parallelogram. Now, the formula for the area of a parallelogram is base times height. We learned that when we did the parallelogram. Well, if I'm looking at the base and height of this yellow parallelogram that I just built, my base is the sum of this B1 and B2. That's the base of this parallelogram. It's B1 and B2. Well, if I were to take that base and multiply it by my height is that 5. It's the distance between my two bases. So my height is my 5. I'm going to multiply that by the base of my parallelogram. Well, the unique thing is, though, I don't want to find the area of this parallelogram. I want to find the area of this trapezoid, and that trapezoid, or this area of this trapezoid, represents half of that parallelogram, and that's what we want to prove to students, that this trapezoid is half of the greater parallelogram. So if I wanted to find the area of that trapezoid, I just have to take the area of this parallelogram here and divide it by 2 or multiply it by 1/2. And that's where we get that formula. Area of a trapezoid equals 1/2 times my B1 plus my B2 times my height. This part right here is where I get that parallelogram, and then the half is what gives me the trapezoid. Some of your students will follow along, some of your students will stare at you wide-eyed. I don't think it's super important that they understand where the formula comes from, but we do want to show them that there is a mathematical purpose behind it. Whether or not they're able to grasp it at this point in time is okay. They'll see it again in geometry, but we want to make sure that moving forward they feel comfortable using the formula to solve for the area of a trapezoid. And alright, that concludes our foldable area of polygons, looking at the proofs. You've got a lot of extra practice problems in the foldable as well that you can use with your kids. But good luck, and hopefully you can use this video to refer back to if you need some help.